Hey guys, welcome back to another video on the Monkey Mathematician, and today we'll be looking at the concept of multiples and factors. And so today our learning objectives will be to learn the concept of multiples, learn the concept of factors, learn how to find the lowest common multiple of two or more numbers, and learn how to find the highest common factor of two or more numbers. So start off, we're going to look at what multiples are. So multiples are the numbers that are the product of an original number and a positive integer. A multiple of a number is the multiplication of that number and a positive integer. So as you may see here, it shows that for 2, the multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, and etc. And how 2 follows is that it will first start with 1, 2, 3, 4, 5, 6, 7, and 8. So it will go linearly, that it will first multiply 2 by 1, then you multiply by 2, then 3, then 4, then 5, then 6, then 7, then 8. As long as they are all positive integers that you're multiplying with 2, then the answer or the product will be counted as a multiple of 2. The same goes here for 3. 3 times 1 gives you 3, 3 times 2 gives you 6, 3 times 3 gives you 9, 3 times 4 gives you 12, 3 times 5 gives you 15, 3 times 6 gives you 18, 3 times 7 gives you 21, and 3 times 8 gives you 24. And you can keep going on with like 9, 10, 11, 12. It doesn't really matter, but as long as you understand that it must be multiplied by positive integer, which is a whole number that is greater than 0, then it will be counted as a multiple of that number. 4 also goes with 4 times 1, 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, and 5 also goes with 5 times 1, 5, 5 times 2, 10, 5 times 3, 15, 5 times 4, 20, 5 times 5, 25, and 5 times 6, 30. So with that being said, we then go on to the next concept, which is the lowest common multiple. Now, the lowest common multiple is an interesting one, where it is the lowest possible number of two or more numbers. Now, an example can be given with finding the lowest common multiple of 4 and 7. So what they want you to do, there are actually two methods to this. The first method is by stating out multiples of the two numbers. So you can see here that by stating out the multiples of 4, starting with 1, then 2, which is 8, 3, which is 12, 4, which is 16, 5, which is 20, 6, which is 24, and 7, which is 28. They stated a good amount of these numbers. Then for 7, they stated it up by doing the same thing as 1, 2, 7 times 2, 7 times 3, 7 times 4, 7 times 5, and 7 times 6. Then what they do is that they compare both multiples, and they are meant to find the first multiple that can be seen in both numbers. And that multiple here can be 28. Another common multiple of 4 and 7 is 56. But we're finding the lowest, and the lowest here is 28. So lowest common multiple, or LCM, of 4 and 7 will equal to 28. Now this is the first method, and a second method was found where it's kind of easier than just stating out multiples, and that is the tabular method or the prime factorization method. Here you put both numbers together, 4 and 7, and then you kind of make a table, where they'll both be put into two columns, or two columns, and then you state out the prime factors that can be used to divide them out. So in some cases, in this case 4 and 7, they do not have any common factor that can be used to divide them out, but you must find the factor that can be used to turn both numbers into 1 at the end. So in this case 2 can be counted as a factor, with 2 being here. 4 divided by 2 will give you 2. And you don't even need to multiply. You don't even need to divide 7, because 7 will give a remainder when it's divided by 2. The same goes here. Here you can do 2 again. So 2 will be dividing this whole thing, and so now will be 1 and 7. Then you take the next prime factor that can be used to divide both of them, and that is 7. So in the end, it then gives you 1 1, and then you can stop the prime factorization. And so you then multiply these free prime numbers, and that'll give you 2 times 2 times 7, and that'll give you 28. The same can be said here, but this can be an easier method if you're trying to, if in some cases they can give you some long numbers. So like for example 8 and 9, that can be seen as the same thing. Divide this by 2, that'll give you 4 and 9. Divide it by 2 again, that'll give you 2 and 9. Divide it by 2 again, that'll give you 1 and 9. Divide it by 9, now divide it by 3, because the next common factor is 3. Divide it by 3, that'll be 1 and 3. And divide it by 3, that'll be 1 and 1. So that will then be 2 times 2 times 2 times 3 times 3. And then that will give you the 8 times 9, 72. And that will be your lowest common multiple for 8 and 9. So we then go on to the next one, and that is, with that being said, we then go on to the next one, and that's factors. So factors are a whole new thing, and they are the numbers, well, it's a number rather, that can be divided exactly by a number without a remainder. Now, an example can be given here with 12. 12 is a number, and if they ask us to find the common the factors of 12, we're meant to first start from the beginning, e.g. 1. You must find two numbers that can be multiplied to each other that will give us 12. So, for example, 1 times 12 is equals to 12. Let's go to 2. 2 times 6 will equals to 12. Let's go to 3. 3 times 4 will equal to 12. And then if you keep going down, you then see that 4 times 3 equals 12. 6 times 2 equals 12. And it keeps on spiraling downwards. Now, when do you know you should stop? Is when you get to the highest factor number, and that is the number itself. Because note, 1 is a factor of every number, and the largest factor of a number is itself. Because when 12 divides itself by 12, it will give us 1, and that is a whole number. So you can then ignore these parts if they begin to repeat themselves, like 3 times 4 and 4 times 3 are the same thing. So if they begin to repeat themselves, you can cut out the parts that are repeating themselves. So you then take these down ones, which are 1, 2, and 3, and then you take the up ones, which are 4, 6, and 12. And these are going to be your factors for 12. And so the same thing can occur with 20, in the sense that 1 times 20 equals 20, 2 times 10 equals 20, 4 times 5 equals 20, and again 5 times 4 equals 20. So if it begins to repeat itself, like 4 times 5 and 5 times 4, you can then just remove out the first point where it begins to repeat itself, and so you can then count the downward one, which is 1, 2, and 4, and you can count the upwards one, which is 5, 10, and 20. So these are your factors for 20. So after that, we then go on to another concept, which is the highest common factor. So the highest common factor is the highest factor that can divide 2 or more numbers without giving a remainder. This is the most important part. And so an example can be given here with find the highest common factor of 4 and 12. So the highest common factor is, as it says, the highest factor that can divide 2 or more numbers without giving a remainder. So what they want you to do is that just like the lowest common multiple, there are two methods to solving this. First is stating out the factors of both numbers. So in this case, the factors of 4 are 1, 2, and 4. And the factors of 12 are 1, 2, 3, 4, 6, and 12. Now, one can say that the common factors in these two are 1, 1, 2, 2, and 4, 4. So you can then put those two can then put those common factors out and you can ignore the rest. Now, as it says, the highest common factor. So you are meant to take the factor that is the highest, and that factor is 4. So the highest common factor of 4 and 12 is 4. The same. Now there's a second method, and that's similar to the prime factor method, where you put those two together in a table and then you start dividing them by. Now this is different in the sense where you get a prime factor that can divide both of them without giving a remainder. So in this case, 4 and 12 have a factor of 2, so you can divide them by 2. That will then give you 4 divided by 2, 2, 12 divided by 2, 6. The second, now you see that 2 can also divide both of them together. That will then give us 2, which is now 2 divided by 2, 1, and 6 divided by 2, 3. Now, when you get here, you see that 1 and 3, there's no prime number that can divide both of them without giving a remainder. So this is where you stop. You stop where both numbers cannot be divided by any number without giving a remainder. So then your answers will now be, when you multiply these two together, that will then be 2 times 2, and so that answer will be 4. The same thing can go on. For another example, can be like 6 and 39. 6 and 39. Finding the highest common factor of 6 and 39. As you keep on moving, you find out that it's going to be quite easier as of now, even if 39 is a big number. But when you look at it, you notice that 3 can divide both 6 and 39. So you put 3. Then 6 divided by 3 is 2, and 39 divided by 3 will give us 13. Then when you look through, you notice that there's no prime number that can divide both 2 and 13 without giving a remainder, and so your answer will now just be 3. And so the highest common factor between 6 and 39 is 3. With that being said, we can go on to some questions from Cambridge, and the first question here states that find the lowest common multiple of 36 and 48. So we're finding the lowest common multiple. So again, there are 2 ways to solve this, and the first method is by stating out multiples of both numbers. So stating out multiples of both numbers, and so the multiple, so we start with 36, and so we start with 36 times 1, which is 36, 36 times 2, which is 72, 36 times 3, which is 108, 36 times 4, which is 144, and 36 times 5, which is 180. I can also do that for 48 here. 48 times 1 is 48, 48 times 2 is 96, 48 times 3 is 144, 48 times 4 is 192, and 48 times 5 is 240. Now, in some cases, they will most likely not be in the range of just 5 multiples, so you have to keep on going further. But as you can see here, again, lowest common multiple is the first number that is a multiple of both 36 and 48. So 36 is not in 48, 72 is not in 48, is not in the multiples of 48, 108 is not in the multiples of 48, 144 though is in both in the multiples of 36 and 48. So your answer is going to be 144. So the lowest common multiple is 144. Now, the second method can be stated with the prime factorization method, and so let me draw a line here. Second method, prime factorization. Now, prime multiples actually, when you think about it, but you're going to be using prime numbers to solve this. So you put both 36 and 48 in columns, and so you then start dividing both of them with prime numbers. So a first one, an easy one, is 2. You must find the prime number that can divide either one of them or both of them. So in this case, 2 can divide both of them. So 36 divided by 2 is 18. 48 divided by 2 is 24. 2 can divide both of them again. So 18 divided by 2 is 9. And 24 divided by 2 is 12. Now, 2 can divide 12, but not 9. So we'll keep 9. We won't act upon 9 because 2 is not going to be affecting it. But 2 will affect 12. So 12 divided by 2 is 6. Now, again, 2 can also divide 6. So 9 will be kept at rest, will not be affected, and 6 divided by 2 will give us 3. Now, 2 cannot divide both of the numbers at all. So we go on to the next prime number, which is 3. So 3 can divide both 9 and 3. So 9 divided by 3 is 3, and 3 divided by 3 is 1. Now, 48 has reached 1. So we don't need to touch on 1 again. We now have to get both of them to 1 and 1. So 3 is here, and so we then divide it by 3 once again. So 3 divided by 3 is 1, and 1 will stay constant, so 1 is here. So now that you have completed the LCM in this case, you then just multiply all these numbers together. So that would then be equals to 2 times 2 times 2 times 2. Then multiply it by 3 times 3 times 3. In indices or in powers, that was written as 2 raised to the power 4 times 3 squared. And so this would then be 4 times 2, 8. 8 times 2, 16. 16 times 3, 48, and 48 times 3 will give us 144. Now that's for LCM. So in our question can be seen with find the highest common factor of 45 and 105. Now same thing, the first method is finding bringing out the factors of both numbers. So factors of both. Now the factors of 45 can be seen with the first one, which is 1 times 45. The second one, we look for a prime number that can divide 45 without giving a remainder, and that will be 3. So 3 times 15. Another one can be 5 times 9. And with that being said, if you keep on going, we'll then reach 9 times 5, and that will not cut it because it's repeating 5 times 9. So erase that, and then we'll say that the factors of 45 is 1, 3, 5, 9, 15, and 45. Erase this. So second one is 105. So 105 equals to normal 1 times 105. Then when you divide it by 3, that will then give you 35. When you divide it by 5, that will then give you 21. When you divide it by something like 7, that will then give you 15. And then if you keep on going, you then reach 15 times 7. And again, that will not cut it because it's repeating 7 times 15. And so you stop at that point, and then you say that 1, 3, 5, 7. Your common factors of the factors of 105 are 1, 3, 5, 7, 15, 21, 35, and 105. So now that we have the two factors of both 45 and 105, we then look for common factors. 1 is a common factor, 3 is a common factor, 5 is a common factor, and 15 is a common factor of both of them. So we bring them out. So the common factors are 1, 3, 5, and 15, and then we take the highest common factor, which is the highest one in quantity, which is 15. So the answer here is 15. Now that's the first method, and now we look at the second method, which is the prime factors. So number 2 can be seen, second method rather, can be seen with putting both 45 and 105 again in a tabular form. So we'll look for a prime number that can divide both 45 and 105 without a remainder, without giving a remainder. And so when you look through, you notice that 45 and 105 can be divided with 3. So 45 divided by 3 will give you 15, and 105 divided by 3 will give you 35. Now another prime number, because 3 cannot divide 35, but it can divide 15. So we'll look for the next prime number that can divide both of them without giving a remainder. And so the next number will be 5. Because 5 can divide both 15 and 35 without giving a remainder. And so 15 divided by 5 will be 3, and 35 divided by 5 will give you 7. And then after this, notice that there's no other number that can divide both 3 and 7 without giving a remainder. So we stop here, and then we'll say that the highest common factor of 45 and 105 will be 3 times 5, which is the same thing as 15. Now, these are simple questions, but there's also something to note. A note can be seen that it's not just true numbers that they may ask you to find the lowest common multiple or highest common factor. Sometimes they can give you like 3 numbers, like for example 3, 12, 36. Find the lowest common multiple. Now, something you can do, right, is that you can do the first method, which is stating out the multiples, but you can also do a simpler method, which takes less time, that's just writing out all the multiples of 3, 12, and 36. And that is the same thing as the prime factor method, and that is the 3, 12, 36 in the brackets. Now, you can divide this by 3 because they can all be divided by 3, funny enough. So 3 divided by 3 will give you 1. 12 divided by 3 will give you 4, and 36 divided by 3 will give you 12. Now, 3 cannot divide any of these again, so you can then look at another number. Actually, we shall start off with 2, but now we can continue on. It doesn't really matter where you start off with, as long as the end goal here for LCM is reaching 1, 1, and 1. So the next number can be 2. 2 will then be 1, because it's not going to affect 1. 4 divided by 2, which is 2, and 12 divided by 2, which is 6. Again, divide it all by 2, because 2 can also be affecting here again. So that will then be 1 divided by 2 is not going to affect it, so 1. 2 divided by 2, which is 1, and 6 divided by 2, which is 3. And funny enough, we go back to 3 again, which is then 1, 1, 3. So again, 1 will not be affected by 3, so 1. Again, 1 will not be affected by 3, so 1. And then 3 divided by 3 will then give you 1. So then the answer will now be 3 times 2 times 2 times 3. 3 times 3 is 9, 2 times 2 is 4. 9 times 12 will give you 36. The end goal is to find 1, 1, and 1 in LCM. The same thing can be seen in highest common factor with, again, 3, 12, and 36. We'll look at the number that can divide all 3 of them without giving a remainder. And so, as we look, we'll notice that all of them can be divided by 3. So we'll divide by 3. So that will then be 1, 4, and 12. Now, again, in this case, there's no number that can divide 1, 4, and 12 without giving a remainder. So for HCF of 3, 12, and 16, your answer will be 3. This is for LCM. So to understand this, you must always know that for LCM, you are looking for the lowest common multiple, which is the number that can be seen in both 3, 12, and 36. And for HCF, you're looking for the factor that can divide 3, 12, and 36 without giving a remainder. And with that being said, I'm thankful for all of you guys to be able to have watched this video to understand the factors, the concepts of factors, multiples, lowest common multiples, and highest common factors. With that being said, enjoy your day, like and subscribe for more content, and I hope you understand more. If you have any questions, you can write down in the comments, or you can check my email, which is also in the description below. With that being said,